on it, so just to put a Band-Aid on it without washing it. I'm like, I'm washing my hands. I kind of don't.
Does it hurt when you have your when you have your water on it? Like when you put water on it?
Not really.
Does it hurt? All right.
I just keep on putting hand sanitizer on it because they won't let me put on anything.
Okay. So for those of you who were not here, gram formula mass is always calculated from the formula. So let's say we have water. How do I calculate gram formula mass of water? Put your phones, your ear pods, your whatever the heck those things are called away. Go ahead.
Get the mass of the two H's and then the one O.
All right, so we're going to find what elements are in the compound.
Oh, how much it weighs.
You're going to find out how much each one weighs.
Multiply by how many there is, and then add them. And round to the nearest.
And that's going to be how many grams are in 1 mole. Willow, I'm doing this for you. You ready? Okay. Sodium chloride. You have a sodium, you have a chlorine. You have one of each. Sodium weighs 23, chlorine weighs 35. We're going to get 23, 35, that weighs 58 grams per mole. Let's do ammonia. You have one N, you have 3 H's, nitrogen weighs 14, hydrogen weighs 1, 14, and 3, 17 grams per mole. Copper, you're not taking notes, you're watching for a second. 2 sulfate. You got to write your formula. Copper is Cu. What does this 2 mean? Plus 2 charge. Sulfate has a minus 2 charge. Cross them down. We end up with CuSO4. Okay? Again, I'm going to start going faster in the sense that this stuff... Uh-oh. What happened? You got lost?
Yeah.
Talk to me. This 2 came down here. This 2 came down here. Because they were the same numbers, they reduced to 1 and 1.
Oh, they like added?
They didn't add, they reduced. So this is a ratio, 2 to 2. It reduced to 1 and 1.
Oh, the SO4 is already
The
there.
SO4 is a polyatomic ion. So you don't touch the subscript of a polyatomic ion. That stays the same. You only touch what you bring down.
What makes it like the 2 in the middle? I know that was like...
This?
Yeah. No, that one. Yeah.
Because it said copper 2 sulfate, I had to put a 2 there. If I had said copper 1 sulfate, then this copper would have been a plus 1. The sulfate would have been a minus 2. I would have taken this 1 and I would have put it down here. And this 2 and I put it down here. I can't reduce those any further. So it would have been Cu2SO4. So this is copper 1 sulfate. This is copper 2 sulfate. Okay? This Roman numeral is the charge. Alright, so if you have copper 2 sulfate, CuSO4, what's the gram formula mass of that? You've got a copper, you've got a sulfur, you've got an oxygen. Okay, 4 oxygens. Copper weighs 64, I'm getting that from my periodic table. Sulfur weighs 32, I'm getting that from the periodic table. And oxygen weighs 16. 15.99, we rounded to 16. 64, 32, 64, 4 times 16, 64. Add these suckers up, 160 grams per mole. Okay? That's how you do gram formula mass. Okay? Now we are using the gram formula mass rounded to the nearest whole number. Sometimes they round it to the nearest tenth. Sometimes they round it to the nearest hundredth. You kind of just have to look. And we will talk a little bit about rounding rules today and Monday, because I don't know how far we'll get. Matt, put that away. All right. The next thing we're going to do is I'm going to say to you, if I walk over to you and I hand you 18 grams of H2O, I hand it to you. Here you go. How many moles of H2O did I hand you? 1. If I hand you 36 grams of H2O, I handed you 2 moles. Okay? If I did that, if I handed you 18 grams, which we know is 1 mole, how many individual H2O molecules did I hand you? That big number. Because a mole is a group, and that's how many are in that group. Okay? If I hand you 36 grams of water, which we now know is 2 moles, then I would have 1.2 times 10 to the 24th? Yeah, times 10 to the 24th.
Why didn't you just take the top thing and put in parentheses and multiply by 2?
What?
Yeah, like 6.02, that top thing, I would think to put parentheses around and put a 2. Yeah.
Yeah, what's 2 times 6.02 times 10 to the 23rd?
I don't know.
12.04 times 10 to the 23rd. Right? Take your calculator out.
So if you reduce it by 1 more.
So if I do this, then this becomes 24. 1.2 times 10 to the 24th.
Can I just do the top with parentheses? With the parentheses?
Take your calculator out.
Divided by 10. She put sugar beets. I don't want your sugar beets.
I can't read that.
It's a calculator. It's the math. I'm trying to.
It just changed. What did it? Wait. Put that back. Oh my gosh, my glasses are so dirty. 1.204. Yeah. 1.204 times 10 to the 24th. This is scientific notation. It's stupid. All right, well, it's about to get stupider. Okay, so here we go. You ready? Let's say I give you 9 grams of water. How many moles would I have given you? 0.5. If I give you 0.5, 3.01 times 10 to the 23rd.
He's locked in.
He is locked in. Guys, take out a calculator. Look. All right, take it out. 6.02. Now, when you do your calculate, stop talking because you're not going to know what you're doing. I want you to start doing it with this little E symbol. That E symbol means times 10. So when you put in 6.02 E23, okay, it should be right above the 7. You might have to hit second E. It says EE. Do you see it? Okay. That number is this Avogadro's number right here, 6.02 times 10 to the 23rd. That's the E, times 10. Now hit times 0.5. It should say EE or E.
That's a weird looking E. Okay. Yeah, that's. Oh, you got it.
You found it?
Figured it out.
Okay. Okay. All right, let's not worry about these numbers right now because that's sending you guys over the edge. All right, what about if I gave you 0.86 grams of H2O? Because that's what's coming. So how do you know how to change a number like this? You knew these, but if I give you a number like this, how many moles do I have? Okay? Turn to the back of your reference tables, table T, as in taco, as in terrible tacos on Thursday. Terrible tacos on Thursday, terrific tacos on Tuesday. Okay, about the second or third, it's the second box down. It says mole calculations. Everybody see it?
Yeah.
Okay, and there's a formula. And that formula says moles equals grams, and they say given mass is given in grams, divided by gram formula mass. This top number is grams, and it's given to you. In this case, I gave you 0.86. Okay? The bottom number, which is gram formula mass, comes from the formula. In this case, the formula was water. Moles equals grams over gram formula mass. How many grams did I give you? 0.86. What was the gram formula mass for water? 18 grams per mole. So what we'll do is I'm going to clear this. 0.86 divided by 18. Oh, that's an ugly number. 0.0477777778. I don't know. It's a lot. 1, 2, 3, 4. I got 6.
Wait, how do we know that? Oh, never mind.
1, 2, 3, 4. Is it 6 or 7? 1, 2, 3. It's 7. Okay. So 0.0477777778. All right. Can we all agree that this is an ugly number? So we got to round it. We can't leave it like this. We can't leave ugly numbers. Okay? There are rounding rules. Okay? And I'm going to teach you those rounding rules right now. Science people made these rules. Okay? So let's take a little side trip. Cordelia, focus, please. Okay. When we have, in science, if we have instruments, measuring instruments, the numbers that we get can only be as precise or as accurate as the least precise measuring instrument that we have. So if you have an instrument that measures only 1 pound, 2 pounds, 3 pounds, 4 pounds, it is not going to be as accurate as if you had something that measures 1.1 pounds, 1.2 pounds, 1.3 pounds. Okay? So when we measure in science, we can only go by our least accurate number, our least accurate measurement. The accuracy of those numbers is dependent on something called significant figures. Anyone ever heard of them? Okay. If you had Mr. Monty last year, anyone have Mr. Monty last year? No. He does significant figures with his class. I don't think Mr. Solomon or Dr. Skaggs did. Okay? There are about 6 rules that we need to follow when we are doing mathematical calculations. The first thing we need to do is we have to figure out how many of these numbers are accurate numbers when we write them down. Not every one of these numbers is an accurate number. It's not a measured number. It's given to us because it is mathematically obtained, and we've got all these numbers that come out here, but they were not measured. They were not measured precisely with an instrument. So what we're going to do is the first thing is we're going to figure out how to determine significant figures. So the first rule is any non-zero digit is significant. Okay, buckle your seatbelts. That means 1, 2, 3, 4, 5, 6, 7, 8, or 9. They're going to count. If you see them written down, they're counting. So if I give you an example like a number like 548, how many significant figures or how many significant digits are in that number? 3. 1, 2, 3. The 5 counts, the 4 counts, and the 8 counts. Okay? So this sucker has 3 significant figures. If I do 9,841, that has 4 significant figures. Notice I have not introduced any zeros yet. It's the zeros that get a little shady. You know those shady zeros. Okay, you with me? Okay, first rule. Everybody's got it. If it's a number that's not a zero, you're going to count it. Rule number 2. Initial zeros. Never count. They're not significant, ever. So, 0.043. There are 2 significant figures. Very good. Because, everybody's eyes up here, after you're done writing, I want to see everybody's eyes. Rule 1 says number 4 and number 3 are significant. Initial zeros are any zeros that are to the left of the first non-zero digit. That's initial zeros up here on the left-hand side. They never, ever, ever count. Don't count them. I could have 8,000 of them. They're actually called placeholders. How many sig figs does this sucker have? 1 sig fig. It doesn't matter how many you have. They don't count if they're to the left of non-zero numbers. Okay. Rule 3. We got 2 out of the way. Rule 3. Sandwich zeros. Yep. Sandwich zeros. Always count. Okay. What's a sandwich zero? You are on fire, girlfriend. All right. So, let's say I have 505. Rule 1. The 5s count. Rule 2. Anything to the left of the first 5 doesn't count. Good news, we don't have any. Rule 3. This 0 is sandwiched between 2 significant digits. So they count. Okay? If it's in between, they count. So this sucker has 3 sig figs. Okay? 9009205. I don't know. That's a bad number, but okay? They're all significant. 9925. They all count. These 2 are sandwiched between the 2 9s. This one's sandwiched between the 2 and 5. So therefore, they all count. How many is that? 7? 7 sig figs. Sig figs. Rule 4. Yes, this is the last one. This is the last one for determining sig figs. Okay? Trailing zeros. So where do you think those suckers are going to be? On the end. Only count them. There is a decimal point in the number. So 500, written like this. Okay? Rule 1. 5 counts. There's nothing to the left, so I don't have to worry about that. There's no sandwiches, so I don't have to worry about that. The zeros at the end. Is there a decimal point in this number?
Yeah.
No. You see it with your eye? No. So because there was no decimal point written, these 2 zeros do not count. If, however, I wrote it like this, now those zeros count. Because what that decimal point is telling you is that the instrument that you used to measure that 500 at least measured these 3 numbers accurately. And that the next number that's out here is the one that we're estimating. Okay? That's what it means. So, here's a number. 0.0520300. Okay, go in order.
So the first 2 zeros don't count, and then 5 and 2 and 3 count, and then the one sandwich, and then the zeros at the end count.
Why do the zeros at the end count?
Because there's a decimal.
Because there's a decimal, so these count.
Wow. Oh my God.
So it's not hard, it's just 4 rules, right? There's zeros up here never count. Zeros in the middle always count. Zeros at the end count if there's a physical decimal point anywhere in the number. Doesn't matter where that decimal point is. It could be all the way out here. How many sig figs does this sucker have? 3. 3 sig figs. Okay. Now we know how to figure out how many significant figures we have. You with me, Rob?
Yep.
Okay. The next thing we're going to do is we're going to add and subtract. These are the rounding rules now. Okay? There's 2 more. Add and subtract and multiply and divide. So if we add and subtract 2 numbers, we have to know what to round them to. So give me some numbers. 4.91 and 3. What? 560. Stick it on there for now. Okay? It's not a great number, but we'll add them together. 0, 7, 14, 8. 8.470. Okay? When you add and subtract, you round your number to the least number of decimal places. I should have made that a 1. It would have been easier for you to see. This guy only has 2 decimal places. 2 decimal places. This guy has 3 decimal places. So my answer can only be 2 decimal places. So 8.47. That's my answer. Let's do another one like that. Sorry. I'm on a roll here. Call me butter because I'm on a roll. I have to amuse myself somehow. In a minute, I'll put them on. We have 1 more rule to go. Then I'm going to go back to the mole calculation and show you how to apply it. All right, let's do another example of add and subtract. Let's do 19.48 minus 7.36431. Okay? I don't know. Just go with it. Okay? Put that in a calculator. Let's get a number. So 19.48 minus 7.36431. 12.11569. Did you get that? It's subtraction.
I didn't plug it in actually.
Oh. Somebody check my math, please. All right. Now, you see how this number is ugly? Okay. This right here, these 3 zeros, I put them in as placeholders. Okay? They're really not there. Let's get rid of them for a second. So, this guy has 2 decimal places. This guy has 5. What do we round our number to? 2 decimal places. So, it's 12.12. 12.12. That's your answer. Not hard. Because I'm going to show you how to apply it to this. And you remember this problem we were just doing where the number was really ugly? Somebody's going to say, what do we round it to? Don't put this number down. But this is this is divide, so I have to do 1 more rule. Okay. Last rule. Oh, stop complaining. All right, multiply and divide. All right. When you multiply and divide, you round to the least number of significant figures. So let's do one. 9.6 divided by 14.31. No thanks. No thanks. 9.6 divided by 14.31. 0.6708595388. Ugly number. When we divide, multiply and divide, we round to the least number of significant figures. Well, how many sig figs does 9.6 have? 2. And what about 14.31? 4. Not decimal places, significant figures. So our answer has to be in 2 significant figures, which means our answer should be 0.67. Okay? That tells you where to round. So everybody who says, what do I round it to? That's the rule. When you multiply and divide, you need to round to the least number of sig figs.
You said this was on the left don't count, so they still write them?
This, yeah. Because really what we should do, if you really want to know, we should take it one step further and put it in scientific notation.
No, thank you. Thank you.
That's like extra. That's like really
It's actually a -1.
Yeah.
Okay?
I like the 0.
Yeah.
So that's why this has 2 significant figures. Okay. All right, one more to practice. 5.9 times 0.08. 0.081. Change the number of significant figures. 5.9 times 0.081. Oh, shoot, I shouldn't have put that 1 on there. All right, anyway. 0.4779. How many sig figs does this get? How many does this have? 2. So what's our answer? 2.48. That's your answer. Okay? What? This has 2. And this has 2.
Oh, the significant. Sorry. I locked out.
She took a mental break. So, let's go back to the question we were just doing with this moles. Okay? And you plug it into... Stop talking, please. You put it into your calculator. You put it into your calculator, and you get this ugly number. And then somebody inevitably comes up to me and says, what do I round it to? Okay? How many sig figs does this 0.86 have? 2. This number is a gram formula mass. It has nothing to do with a measured instrument. So you don't take into account its significant figures. So it has 2 significant figures. So what should the answer here be? 0.0 what? 0.048. 2 significant figures. This 0 doesn't count. You forgot about that little rule, right? So this should be 0.48 moles. 0.048 moles.
Birds.
What? Birds.
Okay, we're done.
On Monday, next week you're having a quiz. And yes, this will be on it. Sig figs, I'll put 1 or 2 questions on there.
Okay.
So please memorize your rules.